Yeah, so we do something on temperature scale. Now, in temperature scale, to come up with a scale of temperature, 2 points are needed, and these 2 points are called the fixed points. There's an upper fixed point and a lower fixed point. So we have two types of scales. We have a Celsius scale and a Kelvin scale. So the two fixed points are on the Celsius scale. The lower point is the temperature of pure melting ice, which is always at 0 degrees C. And the upper fixed point is the temperature of steam or boiling water, which is at 100 degrees C. So these points, we're talking about 2 points here. There's a lower fixed point, which it is at 0 degrees C. And we are talking about a higher point, or the upper fixed point, which is at 100 degrees C. Now, once these two fixed points have been obtained, they are divided into equal portions. So, for example, in this case, it will be divided into 100 equal parts, each one. So, we have 1 here, maybe 2 there, 3, 4. So, this will be 1 degree C. This will be 2 degrees C, 3 degrees C, until you reach 100 degrees C. That is how temperature scale is arrived at. Now, we are talking about those 2 points. So each division of the fixed points is called a degree. Each division is called a degree. Now, if you look at this diagram, this is how a lower fixed point is obtained. The ice, the temperature is taken and put into melting ice. So the mercury inside the thermometer will contract. So the maximum contraction until that point where the ice is melting and there's no temperature change, no change in the level of the mercury, that will be the lower fixed point, which is the melting point of ice. Then the same temperature is transferred into boiling water. So as the steam comes out, the mercury will expand. So it will expand until a point where boiling starts. So at that maximum point where the boiling of this liquid will be happening without any rise in the liquid, that will be the upper fixed points. So if these 2 points are analyzed, we are going to have the thermometer indicated at C, the thermometer that is indicated on the right. So that is how the temperature scales are fixed. Now, what are some of the features of a common thermometer? Remember, we have different types of thermometer. We have the common thermometer, the one that is used in our labs for practicals. We have the clinical thermometer. This one is used in hospitals to determine the temperature of a patient. We have the maximum and minimum thermometer, what we call the 6 thermometer. That one also is used in the weather stations and such places. Now, what are the features of a common thermometer? If we look at the ordinary thermometer we have in the laboratory, what are some of the common features? Now, there's a diagram here that shows us a common thermometer. So some of the features of a common thermometer, we have a bulb. Now, the bulb is the one that carries the liquid in the thermometer. So the liquid, which is mercury in our case here, is first filled into the bulb. Now, the bulb has a thin glass wall for effective heat transmission. It is made up from a very thin glass wall. So it is very sensitive to any slight changes in temperature. And the moment the heat reaches the mercury inside, that mercury will expand. So therefore, we say the main role of a bulb is to hold the liquid in the thermometer, and also it has an adaptation in that it is made from a very thin glass, which is very effective for heat transmission between the liquid and the body whose temperature is to be measured. That is basically if it is hot water, if it is just temperature of a reaction, it can easily detect that. Number 2, we have the capillary bore. A capillary bore is a hollow part where the liquid inside expands or contracts when the heat changes are detected. So this capillary bore is narrow. The reason why it is narrow is for high degree of accuracy. Then the next one is the glass stem. The glass stem is what we see on the outside of the thermometer. Now this glass stem does 2 roles. Number 1, it acts as a magnifier. It enables us to see the scale properly or clearly in a magnified way. And then also it protects the mercury inside. So it is transparent, we can see through it. It is a magnifier, therefore it can also make the scale appear a bit bigger. So we're talking about the 2 scales. There's a Celsius scale and a Kelvin scale. The both scales are used to measure temperature. Now the Celsius scale has fixed point, as we said, from 0 degrees C to 100 degrees C. And then the Kelvin scale has the fixed points at 273 Kelvin and 373 Kelvin. But one thing has to be noted. If we talk about the Celsius scale, it also have a 0. You can have 0 degrees. It has negative as well, negative 10 degrees C. Those ones can be measured from the Celsius scale. But when it comes to the Kelvin scale, the lowest temperature in the Kelvin scale is 0 Kelvin. We do not talk about negative scale or a negative reading in the Kelvin scale. This is because the 0 Kelvin is the lowest temperature that can be attained. And at this temperature, it is assumed that the energy of the particles in a material is 0. So we cannot have any energy beyond 0. So at 0 Kelvin, the particles do not possess any energy in them. So that is the reason why we do not have negative in the Kelvin scale. Now that lowest temperature we are talking about in the Kelvin scale is 0 Kelvin, is called the absolute 0. And we've said it is the temperature at which the energy of these particles within a material is 0. Now we can interconvert between the Celsius scale and the Kelvin scale. To change degrees C to Kelvin, you simply add 273, which is a constant. And to change Kelvin to degrees C, you subtract the same constant, 273. Now we are having an example here. Look at this example. You're told convert each of the following temperatures into Kelvin. We've said whenever you want to convert degrees C to Kelvin, you add 273. So in number A, for example, we're given 25 degrees C. How do we convert 25 degrees C to Kelvin? We will add 273 to that 25. That will give us 298 Kelvin. If we convert 100 degrees C to Kelvin, we simply take that 100, we add 273. We will get 373. So that's the conversion. If you want to convert, let's say, Kelvin to degrees C, as in example 2. So I said when we are converting from Kelvin to degrees C, you need to subtract the constant, which is 273. So if you look at number A, for example, for us to convert 350 kelvins to degrees C, we will simply take that 350, subtract the constant 273 from it, and then you will get 77. So 77 will be the temperature in degrees C converted from 350 Kelvin.